Right, so good afternoon, students, and welcome officially to our first lecture today. The course title is Quantitative Methods, and from now till
I am Lisa.
we have to go through the quantitative methods. Meanwhile, I need to mute all of you so I can have a proper flow. So all of you are muted. If I open the floor, then I can ask you to unmute yourself, right? So this is the first time I'm meeting you, and my first slide is showing my name far right below. And then you have the course title, Quantitative Methods. Now, these are some basic information I want you to know for our course outline. So I will load it in the LMS for you in the course of the week. I'm yet to set up your LMS, but it will be done this week. Now, the second slide also has information about me. When I upload it on the LMS, you can fully go through every slide you need to go through to know about the course we are doing, as well as your facilitator. Now, there are some important points in this course outline I want you to know today before next week, and it's going to help you a lot. So I'll skip all the ones you can read yourself, and then where I want to highlight, I'll just speak on them. For instance, slide number 6 is the course requirement. And so when you are doing quantitative methods, it is a foundation for another math course you do during your second semester called data analysis and interpretation. And for the data analysis, sometimes you need a laptop to analyze your data, or a desktop. So if you don't have any of them, and then you can have somebody's laptop or desktop, just start making arrangements so that when we start the data analysis and interpretation, you can be able to follow what we do. But for this course, all you need are two things for now. First of all, you need the calculator by name FX991ES Plus scientific non-programmable calculator. And the brand is Casio. Most of them know it already. These are the calculators that are used in the secondary schools for the WASI exams. So try and get one for our various calculations we'll be doing. And then, of course, once you are connected to me, it means you have a smartphone. If you are connecting with your smartphone, because that's what you are going to use for your lectures, online lectures, video lectures, and then the assessment assignments that I will mount up in the learning management system. I'm using LMS because I'm presuming you have been walked through the learning management system. That is why I keep referring to it as the LMS. So for this slide page, the second point and the first point are very important. Then from there, I want also to show you another slide page, which is actually showing the structure of your assessment. So everything we do, all the concepts we are about to learn and how to apply them, there are some tasks and then outcomes that are needed. So assignments will be mounted on LMS for you to do for a mark. And then the mid-semester also will be mounted in the LMS for you to do for another mark. But the final examination will be in person. You may have, if things do not change, you may have to come and write the final exam in the school in person. And so these are the percentages or mark percentages for the assessment. Assignments, I award 20% maximum. Mid-semester, I award 20% maximum. And then the final is mandatory by the school is 60%. So these three makes it the 100%. So this will be the structure of your assignment. And the objective is to check your knowledge in what we are doing and also to see your creativity and critical thinking skills. The school has a grading system, which I have labeled as the GCTU grading system. It shows you the marks range, the grade you get for the range, as well as the interpretation. So at the end of the day, if what I just displayed for you before this one, if I put all your assignments marks together, and then I add it to your mid-semester exam, and then I also add it finally to your final semester exam, then these three, the total marks you get here will have to fall within one of these ranges. So for instance, if you get between 80 to 100, it means you have grade A, and the interpretation is outstanding performance. If you have between 79 to 75, at the end of putting all these three together, you have A minus, and the interpretation is excellent. If you get between 74 to 70, the grade point is B plus, and the interpretation is very good performance. Between 69 and 65, that is grade B, and that is a good performance. Between 64 to 60, you have B minus, and that earns you a fairly good performance. Between 59 to 55, you have a grade of C plus. The interpretation is an above average performance. If you have between 54 to 50, the grade is C, and then the performance is average performance. Now, ideally, all the ones above are the recommended ones you have to study hard to attain. Your performance should not be below average. If you let your performance come below average, you are going to run into problems. So you have to take advantage of the assessment structure so that you make sure all assignments mounted, you do them, or the mid-semester that will be mounted, Also, you have to do it. And then have to also come in person to do the final exam to get a good grade. Because all the grade below average are bad. They are not going to help you. Even though when you have between 45 and 49, you haven't failed. You have passed. It is below average, but you have passed. Again, if you score between 44 to 40, that is also not a failure. You have recorded D, and that is a pass. But the moment you get 39 and below, it's a straight F. And once you fail, you have to resit the exam. So avoid this last three. Try and avoid this last three and make sure that your worst case scenario performance, that is, if things do not go well for you, you simply come and lie at the last recommended grade, which is a grade of C, between 54 to 50. So this is the grading system. And I spent a lot of time here because at the end of the day, when you finish the school, this is what people are looking for on your resource slip. Anytime your resource slip is checked by any institution, all they want to know is what did you get? What grade did you get in the various courses? So this is like the final product of all your sweat and wahala you are going to go through every weekend to join a class, to do assignments and all those things. It has to reflect here. All your hard work will have to reflect on this. And I'm going to use this today to explain to you the reason why it is always important to make sure you don't go below grade C as one of our examples today. So this is enough for the grading system. And it applies to all the courses. It applies to all the courses. Now, you're also supposed to take advantage of the LMS because that is your main dashboard for your program, the LMS. You have to master the LMS. You need to know how to navigate through every corner of the LMS. And I'm sure my colleague who is in charge of that will walk you through the LMS as and when necessary. And all the questions you have on the LMS, you can ask him to explain to you. Finally, on our course outline, I want to give you an idea of what we will be doing. We have our course schedule and the topics that we are supposed to treat. This is level 300. This is not level 100. So it is presumed that you have knowledge about the things here already when you were doing your diploma or HND or whatever qualification you had, or you moving through from level 200 to level 300. The quantitative methods will always build from the foundation you know already, from the course title, Business Statistics. Business Statistics. So any statistics course you have done can be a good foundation for the quantitative methods. And it's part of your program because at the end of the day, when you get to the final year, you will be doing your project work. And in your project work, there are two things that you are supposed to focus on. Now, the first one, and then the second one. The first one is the course title, Research Methods. Research Methods. And I'm sure either you are doing it or you may do it later. So research methods will really outline all the various components you will need for your project work. All the components you need for your project work. Then what we are doing, quantitative methods, will help you to do your data analysis. That is why we are spending time on this course. It is going to be your tool for data analysis. You are going to measure some statistical metrics. And once the metrics are measured, you have to interpret the metrics. And so within this course, we will start learning gradually how to do interpretation of results. That is going to help us. Once we start doing interpretation of results, then it means that when we start the data analysis, we can be able to interpret our results. And so it is quite a loaded area, and I'll try and do them snappy for you. Textbooks that are holding this course are running into thousands of pages, but I've tried to simplify as much as I can for you to be able to comprehend them within a short time. So first of all, we'll go through the recap of statistical measures, descriptive statistics, and I'm sure you remember what a mode is, what a median is, and then what a mean is. Okay, so we'll go through descriptive statistics. We'll just recap with an example to help you recollect how to find the mean of data and then how to find the standard deviation of data. So this is what we are going to do to this topic. We are going to look at the what, the why, and the how of doing the mean of data and the standard deviation of data. So once we have that foundation, which hopefully I know we will finish this one today, it will give us the encouragement to move on to probability theory, which is more advanced than the statistical measures. And as we go through the weeks, we'll come to sampling distributions as well as significance testings. And then we end with correlation and regression, or what we call the regression statistics. So in short, we are starting with descriptive statistics, and then we'll end with regression statistics. So this is the end of the course outline. I want to open the floor for the first time to pick or take any question. If you have any question on what I've presented so far, please, you can raise your hand, ask your question, and then I can address your question. Any questions so far from what we have done before I continue? Any questions so far? All right, so if there are no questions, let's now continue our first topic for today. Now, the course title is Quantitative Methods. Quantitative Methods. And then our unit 1 is Descriptive Statistics. But let's even try and look at quantitative methods first, and then we can look at our first topic today. The question is, why must we apply quantitative methods in organizations? Not only one organization, every organization, from social to security, they all do apply quantitative methods. So if your foundation is weak in school, when it comes to the application in the industry, sometimes it becomes a big problem. So you need to have a firm grip of quantitative methods before you can apply them. Now, there are two words I'm sure you've come across before. And these are the two words. I'm sure you've heard about quality. The word quality before. And then you've also heard about the word quantity. So these two gives us two different ideas. Quality is non-numeric. Now, when we say non-numeric, it means it is not reported in the form of a number. Okay. But quantity is numeric. It means quantities are reported with numbers. Example, let's look at examples of quality. If I have 3 colors, red, yellow, and then green. If I ask you to describe their quality, it will be very difficult for you to assign numbers to them. You can't say red is better than yellow or yellow is better than green. As for this side, it will be one's opinion. It will be the opinion of people. It is not you who can determine that red is better than yellow, yellow is better than green. So when you are doing such comparisons, these ones cannot be quantitative. It can only be qualitative. Or there's another word called categorical. You can just put them into categories, but you cannot make them look like they are numeric. And then when it comes to quantity, quantity means you are dealing with numbers. So when I write 80, and I write 100, and I write 200, without blinking your eye, you know which of them is the biggest. and then which of them is the smallest. Why? Because they are numeric. Numbers are assigned. And so we look at their quantum and then we make our judgments. So quantity, quantitative, quantity, quantitative methods presupposes that we are going to deal with numbers when you see quantitative methods. And so why must organizations apply quantitative methods? It's because, like those of you in business already, always in business, there is a decision-making process because you always have to review your business. Once you review your business, either you have challenges or issues that are fighting against your business. Once you see the issues, you then solve the issues. Okay. So the decision-making process is continuous. It's continuous. It's not constant. It's continuous because the decision you probably took today may only work for today. It may not work for tomorrow. So it means that tomorrow you need to take another decision. So this decision-making process, most of the time, is used to improve. That's the word I can use. It's used to improve the business. So if the decision-making process is used to improve the business, how do we go about the decision-making process? Do we sit down and say, I think, or we say, I want, or you say, I wish? These things do not, the words I've written, do not improve your business. If you say, I think I should do something like this, I think I want this, I wish I had this, these things will not improve your business. The only way your business can be improved is to apply quantitative methods. Once you apply the methods, there will be an improvement, or you will have a blueprint that can lead you to improve the business or the financial position of the business. So how can the improvement be done? You always have a past data with you. Always you have a past data with you. So you are going to apply quantitative methods on your past data. You are going to apply quantitative methods on your past data. And once you apply it on your past data, you are going to have what we call empirical results. That is, there will be evidence. You have empirical results or evidence that you need to do something. And then out of the empirical results, you will be able to complete your decision-making process. Let me give you an example. Assuming in the evenings, you sell kinky in the evenings, and then you started business. Thursday, Monday, you sent 100 balls, all got finished. Tuesday, You sent 200. All got finished. Wednesday, you sent 300. All got finished. Thursday, you sent 400. And then only 50 was bought. You sent 350 home. And then probably Friday, because of what happened on Thursday, you went back to the Monday issue. So you sent 100, and then again, only 50 was bought. What will go through your mind when you are having something like this, which was progressing, and all of a sudden it started retrogressing? There are several reasons that you can assign to this. Number one, it may happen that from Monday to Thursdays, there are a lot of customers around your joint. That is why all the quantities you sent were finishing early. That is Monday to Wednesday. But Thursday and Friday, it dropped drastically. Sales dropped drastically to 50-50. The reason may be that your customers do not pass by your joint on Thursdays and Friday. That may be one reason. Another reason is that when you were doing well until Wednesday, maybe you had another competitor who has set up somewhere nearer to you and is rather having good customer service. And so all your customers have run to the new competitor. Now, all these reasons we are assigning are being made possible because we are studying the figures, the term of figures we are having. We are looking at the trend, and the trend is informing the decisions that are coming into our mind. So that is what I mean by past data. We need to do something to our past data, get some empirical results to help us complete the decision-making process. When you do something like this, it means that you are applying some sort of science to your management. You are looking at the problem, and then you are trying to find a solution to the problem. As a result, most organizations apply quantitative methods in order to be able to have informed decisions, not ad hoc, informed decisions, because they have evidence or they have empirical results. Now, how do you handle managerial problems? Say we use quantitative methods or techniques to solve managerial problems. And in one of the topics, I will use it to solve a managerial problem for you to know how quantitative techniques or methods are used to solve managerial problem. It is also used to select what we call optimal decisions. Sometimes you have several options. You need to pick one of them. You can apply quantitative methods to be able to pick an optimal decision. Now, specific in business, many company directors base their decisions on experience and gut or ego, because they think they've been doing the business for a very long time. They can use their knowledge of the past to improve the business. And most of the time, they get it wrong. because their experience and their gut is not able to reflect how to predict the trends in business, how to determine the allocation of resources, and how to manage projects. Every project is unique. So sometimes you cannot use past experience to be able to manage a current project. The only ideal thing and safest thing to use are quantitative methods, because you can get a live data, apply the tools of quantitative methods, and then you can get, as I always say, the evidence. You need evidence. You should have an evidence to show you which direction you should move, either downwards or upwards. There must be evidence. And you can get it from the techniques of quantitative methods. Now, in summary, quantitative methods can be put into two broad areas. It is a very big concept, but it is interrelated in two broad areas. Because of the time of our studies and because of the type of project you will do in the final year, I want to go specific with what will help you do a good project when you are called upon in the final year. Basically, quantitative methods can be grouped into two. The first one, we call them mathematical methods for quantitative techniques. And then the second one, we call them statistical methods for quantitative techniques. The kind of project you do, you need to do an analysis which is statistical. So we will concentrate on the statistical methods because of your project. The mathematical methods can be treated during your master's degree if you are intending to read your master's. Your master's degree, we will treat the mathematical methods. But for the undergrad, for now, and for the structure of your project, we'll use statistical methods. And so all our calculations this semester, all our workings this semester, our full focus will be on the statistical aspects of quantitative methods. Finally, before we start our first topic, I have stated here again, and I'm asking, which of them are we using for this semester? If you didn't hear me the first time, I have put it into writing here. I'm saying that to do a good data analysis for your final year research project, we will do the quantitative methods, which has the statistical methods. Statistical methods. So take note of that. Now, within these statistical methods, also, we have another branch called the statistical measures and the statistical testings. So I'm going to give you a recap of the statistical measures, and then we'll take almost 80% of the semester to do the statistical testings, which you will need in your project work. And so, ladies and gentlemen, This is a brief on the quantitative methods structure and why you should do it at this time. I want to open the floor again for the second time for questions. Anything you didn't understand, kindly put up your hand and then let me address it before we start working. And I'm sure some of you have your calculators with you already. If you don't have your calculator, next week, try and get it because I'll be doing it with you. We'll be doing it together. Whilst I compute at my end, you also do it at your end. And then we can reconcile our results. If there are any discrepancies, we can just correct ourselves before the class closes. For the second time, any questions so far from the presentation? All right. So if there are no questions, let's proceed to our first topic today. So this is what I showed you. Said we are doing descriptive statistics, which I know we've done some before, but I'm just going to do a quick recap. I'm going to do a quick recap by picking a question, and then we'll go through the question for you to remember what descriptive statistics is. I'm sure by now you've not forgotten about what a mode is, what a mean is, what a median is. And then standard deviation. If you remember all those things, don't worry if you don't remember them. We'll look at a few of them. But this is the fundamental point we have to start from. So mode, mean, median, standard deviation, and so on and so forth. So I'll start with some illustration. Just watch this grading system. I just showed you the grading system of the school. When I was showing you, I had arranged them vertically, but I'm now doing it horizontally because I want to use it to teach you something. So look at it from left to right. Okay. So it's basically showing you that we are moving from the lowest to the highest. And the lowest is F. The highest is A. Now, there's a concept called average and variability. Average and variability. So once I haven't taught this class before, let me do some demonstration before I tackle this. Now look at the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I ask you to show me the middle number or the center or which number moving from 1 to 10 will represent all these numbers, I'm sure you start coming from the flanks. So it's like 1 is matching 10 at the other side. 2 is also matching 9 on the other side. 3 is also matching 8 on the other side. 4 is matching 7 on the other side. We were expecting to get one number here. That would be the middle number, but we have two middle numbers. We have 5 and then we have 6. But we just want one number. That will be the center number for moving from 1 to 10. So when you are doing these calculations for median, when you have two numbers in the center, you just have to put them together, 5 plus 6, and then you divide it by 2. And once you do that, the final answer you will have will be 5.5. If you use your calculator, your final answer will be 5.5. So what it means is when you are moving from 1 to 10, the center of that journey is 5.5. This 5.5 has several names in life. Some call it the balance point. Now, if you go to those who do engineering, some call it the pivot. It also has another name called the fulcrum. Some just call it the center. But in business, we call it the average. So this is representing an average in business. So if these numbers were to be money, 1 CD, 2 CDs, 3 CDs, up to 10 CDs, we'll say that the average money is 5.5 CDs. How do we know? How do we know that the average is 5.5 CDs? There is a proof to show that. So this is the proof. This is how you can prove that indeed what you have is the center. Now watch this. When you pick 1, now that you have the middle line being 5.5, it means the opposite of 1 is 10. When you pick 1 and you add it to 10, and you want one number, so you divide it by 2, the results you have is 5.5. When you pick 2 and you pick its opposite, 9, and you put them together, 2 and 9, and you divide it by 2, it means you have again 5.5 as representing 2 and 9. When you pick 3 and then you pick 8 and you put them together, 3 plus 8, and you divide by 2, you still have 5.5. The last one, if you pick 4 and then you pick 7 and you put them together and divide by 2, you still come to 5.5. And that is the indication we are having here. That is the meaning of this 5.5. So at the end of the day, the 1 to 10 you are seeing, if we are rewriting it, 1 can represent 5.5. 2 can also represent 5.5. 3 can also represent 5.5 because it has balanced. 4 can also represent 5.5. In other words, any of the numbers on the line because we've been able to successfully identify the center, you can use it to represent all of them as the center. So if you're a business person and you have set what we call your target is the average. Your target is the average. If you move above the target, and if you move below the target, it means a lot. So if we take our situation here, it means that from the calculation we have done, our target is 5.5. So let's say these are business figures. We are selling, and sometimes we get 1 million, sometimes we get 2 million, sometimes we get 5 million, sometimes we get 6 million, sometimes we get 10 million. So after setting our target, which is the 5.5, it means anytime we do sales and we have 6, we have 7, we have 8, we have 9, we have 10. It means that we have exceeded the target, because the target was 5.5. So when you are moving on the right-hand side of the 5.5 to 10, it means that your average has been exceeded, or your target has been exceeded. But when you start recording on the opposite side, 5, 4, 3, 2, 1, even though you have made some sales, you have come below the target. So if there's any promotion, they will give it to those who have exceeded their target. So anytime they set a target for you, that is the average point. When you exceed it, it has a reward. When you fall below the target, it has other consequences. And the worst form of consequence is dismissal. So, assuming you are working in an environment as a new manager and your contract is to work 10 months, and the target the director set for you was to have 5 million Ghana cedis a month. If the first month you had 1 million, nobody will talk. They will just be watching because you have more months to go. Second month, you had 2 million. They will still watch. Third month, you had 3 million. Even though you have not gotten to the target, they are seeing what we call improvement. They are seeing improvement. So their hope is you achieve your target. And then you keep coming till you start recording 6, 7, 8, 9, 10. Then once you exceed their expectation, it means that any award or reward should be given to you. So the first metric in quantitative methods, or the first measurement that we'll always do, the first measurement we always do is what we call the average. That is the first measurement, because that is what is going to set the target for us. So that will be the first measurement. In some books, it is known as the mean. It is called the mean. That is the first metric. because that also serves as our starting point. For every activity, there must be a starting point. So the average in our analysis will become our starting point. And of course, if you have a starting point and there are directions, you can choose to move to the right direction or you can choose to move to the left direction. So the starting point, even though it is important, once you start moving, it means that where you are going, we should also know where you are going to end. We should have an idea of where you are going to end. Any journey that you embark on, once you know your destination, it becomes easier for everybody to calculate. But if we don't know your destination, that will be a problem. So this that I demonstrated, I want to show you how sometimes misleading the starting point can even become. Sometimes the starting point can be misleading unless we have another information called supplementary information to help us to know where we are going. So if I use a real life scenario, if this starting point is Accra, and you want to embark on a journey, either to the right or to the left, you have to show me this destination. So probably here is Kumasi. And then here is Ho. So once you show me the destination, when I take off, I know the distance I'm covering. Probably this one, I have to cover 240 kilometers. And then this one, probably I have to cover 190 kilometers. So this is what you have done to help me. The center alone, Accra, was not enough for me to know where you are going. But what really helped me from where you are going was the distance. It means where you are going, I should measure 240 kilometers from Accra, and then I'll have an idea of where you are going, which is your final destination. Or to the right, when you show me that you are moving 190 kilometers from Accra on a certain highway to a certain town, I just measure my 190 and I know your destination. So the average alone, like I keep repeating, is not enough as an information. We need other supplementary information in addition to the average to be able to complete the understanding of our data. And that supplementary information is what we call the standard deviation. And I'm going to demonstrate that to you. What the standard deviation actually does is it shows you the spread of the data from the center, the spread of the data from the average or the center. Like what I've done here. So in other words, this point in Accra is representing the average. The distance to my right, 190 kilometers. The distance to my left, 240 kilometers, is showing me the standard deviation. Standard deviation means that you are deviating away from the average. So if you look at the first example, when they set a target of 5.5 for you, when you deviate in the positive direction, it means you have exceeded your target. But when you deviate from the average towards the negative direction, it means you have performed below the average. Now, the problem always in quantitative method is how to identify the deviation away from the center. That is what is difficult to guess, because your guessing may be wrong. And let's try an example here for you to understand what I'm saying. Now, the initial example, we did 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We all agreed that the center, we need to combine these two and divide by 2. And when we did it, we had 5.5 at the center. No problem with this. Now, assuming this time the data, we didn't start from 1. We didn't start from 2, but we started from 3. So 3, 4, 5, 6, 7, and then we stopped at 8. If I ask you to show me a number which can be the center of this set 2, which numbers are you going to pick? Say, you are going to pick 5 and 6. And when you put the 2 together, you are still going to record 5.5. Now, is this 5.5 different from this one? No. No. It's the same thing. The same numbers that give you the 5.5 here. You have the same numbers giving you the 5.5 here. But look at the length. This one started from 1 and it ended at 10. But this one started from 3 and it's ending at what? 8. There are 2 different data sets. 2 entirely different data sets, but yet they are giving the same center. So when you are asked to show the difference, what are you going to say? Assuming you don't have these numbers, they just tell you there are 2 data sets. Their center is 5.5. Find them. You wouldn't know. So the center alone is not enough, but the variability. I've started introducing the technical words you need. The variability of the data really helps. The variability will show you the first number of the data and then the last number of the data. So this one, we need to find how 5.5 has a data that can start from 3 and then how it will also end at 8. In the same way, we have to find out how this time 5.5 can also start from 1 and then end at 10. So in short, to completely understand any data you are dealing with, in effect, there are only 2 things you need from the data. 1, you need to find the center of the data, which is called the average. And then the second thing to do is to find the spread of the data. So you are doing two things. You are finding the spread in the center, and the spread is what we call the variability. An example of the variability is the standard deviation. That means you are moving away from the average, from the center to the left or to the right. And that is what I want you to look at. So that was where I wanted to start the class today, but because I haven't taught you before, I needed to give you all those examples I did. So when you see average and variability, they are the first two information we need from data. First two information we need from data. In fact, the first one, which is the average, is called the center. And then the variability is called the spread. So I'm going to use the grade to explain variability to you. Let's look at this. Now, the grading system, the lowest is F, and then the highest is A. So you have 10 of the grades. So when you are asked to find the middle, what do? You do the same thing we did to the 1, 2, 3 to 10. You keep coming from the ends. You keep coming from the corners inside this way. So you see that just like we had the 5 and 6, you come and lock up between these two. So it means that the average grade in the school is either C plus or B minus. C plus or B minus. Now the question is, which of the grades are closer to C plus and which ones are closer to B minus? That is what you are seeing here. You see that B is closer to B minus, and C is also closer to C plus. That was why when I was showing it to you in the course outline, I told you that this should be your last point. You shouldn't go below C. If you go below C, you have gone below the target. If you do that, you have gone below the target. But anything after B minus here, from B minus to A, it means you have exceeded the target. So what target have the school set for you? The school has set this target for you. That worst case scenario, your grade should be between C plus and B minus. That is the target. So you either get the target or you exceed the target. If you come below, it will not be good for you. So what is the expectation of the school? The expectation of the school is not to wish any student to fail. That is not. Other than that, we wouldn't have even given you admission in the first place. And the wish of the institute is not for anybody to fail. But look at what I've written here. The institute expects that most students will fall within this grade in their worst case scenario situations. They won't go below C minus. They won't go below C plus. But the school is expecting that most students, your grade will be around this area. If you are not even academically good, you should be around this area. If you are academically good already, it means that bingo, you move to the right and start recording your A's. The school hasn't set A as a target for you. No. You will have to set this target for yourself. But the target the school has set for you to get a good certificate is C plus and B minus. That is the target. And then you can increase your hard work and then push up to the right. But what the school discourages is for you to come to this other side of the average. That one is not too good for you. So the average point is a point whereby in business, organizations also expect most workers to be. I haven't seen any organization whereby they are saying that everybody should exceed the target. No, they set a target for everybody, every worker, every employee, every officer. You have your target to meet. My target may be different from your target, but everybody's target has been met. So for instance, if I'm to use this one also as an organization, maybe probably all the junior staffs have been given this target to meet. And then all the senior staff have also been given this target to meet. And it is fair because these two places are forming the average range. And once it's the average range, it means that most workers are expected to meet their targets to be in the average range. Now, sometimes there are some considerations. If you don't meet your target, what happens? Assuming they are expecting C plus from you, and then you get C, you haven't failed. Like the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers we arrange. Assuming these are revenue levels, and the target the company has set for you, the manager, is 5.5, and then you end up getting 4. You were closer. Even though you didn't meet the target or expectation, you will be considered as having done your best. On the other hand, if instead of 5.5, you end up getting 1, this is not acceptable because you've gone way, 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 way below the target, and nobody will accept this. So any drastic measures can be taken against you. So even though 4 and 1 are all below the target, but because 4 is a bit closer to 5.5, that one is given consideration. Because 1 is far away from the target, it is not acceptable. And this is what I have labeled as variability. Variability, that is moving away from the average. Variability to the left and variability to the right. So in an organization, the company expects a few employees to be in this area. Just a few employees to be in this area because they know that not everybody can exceed the targets. That is why when you go to some of the banks like EcoBank, you see them putting some portrait there as the star of the month or something. That is the worker who has exceeded the target for the month. They just put the person's image there. So whenever you are varying from the average point, you just have a few people to the right of the average, and then a few people to the left of the average. In the same way, when people are going to be laid off because they didn't do well, you don't have a lot of people. You have a few people. So the variability has two directions. We have the positive direction, which is good, and we have the negative direction, which is not good. And so the distance between the left to the average and the distance between the average to the right is what we call the variability. Variability. If I give you a job and I'm expecting 5.5 million and you hit 10 million, I'm happy with you and I'm surprised at the same time. If I also give you 5.5 million target and you end up getting 1 million, I'm annoyed and I'm surprised at the same time. So both extremes are not good. But if you try and move away from the center, your movement should not be too much. Your movement should be closer to the average. So movements like C plus to C and B minus to B is okay, and it looks normal. It looks normal. There are no surprises. If you are supposed to get B minus and you get B, that's closer. It's not a surprise. If you are supposed to get C plus and you get C, that is also not surprising. But if you are supposed to get C plus and then you end up getting F, this is a big surprise. And then if you are supposed to get B minus and you all of a sudden get grade A, this is also a surprise. So in business, what we encourage in business is what I want to write for you to know about the center and the variability. And then we can pick one question and solve for you to understand what we are doing. Now, in business, we encourage small variabilities. We encourage small variabilities. Why? Because they are safe. In business, we don't encourage large variabilities because that is the opposite of what I've written up there. Because they are not safe. They are not safe. Let me give you an example in Ghana to help you understand the two statements I've written. If you have the US dollar, one, to be changing as, let's say, 5 cedis. Let's say this is January. January, it was 5 cedis. And then the same $1, when we got to December, it has changed to 15 cedis. This will not be acceptable by the consumers because the variability is too much. The thing was at 5. The opposites are 6, 4, 7, 3, 8, 2, 9, 1. So the expectation of the consumers with what we have learned today about the center and variability is that if this is the center in January, we are expecting that either it will drop to 4 or it will increase to 6. If it had happened that way, it is not surprising at all. We will be okay with it. Or we were expecting that it will drop to either 3 or it will increase to 7. This one too is not surprising at all. It would have been received. But look at where 15 is. 15 is here. So far, look at the distance from the center. Very long distance. It starts from here and spreads wider to the side. This is what we call large variability. It is not safe for consumers. But when you have smaller variabilities, it is safe for consumers. Like we are having currently. If we know that now the dollar is between 10 to 12, and this is the center, all we think of every day is that, well, it can either move to 9 or it will move to 13, or it will move to 8, or it will move to 14. We will not be surprised if we see something like this. But we will again be surprised if this thing moves to, let's say, 20, and then this one will move to $1. We'll be surprised that now you have $1 equals 1 cedi. This will be a big surprise for us. Or you have $1 moving from 12 cedis to 20 cedis. It will still be a surprise for us. But where we will not be surprised is when the dollar moves to 13 or 14 or 9 or 8. It is not surprising because we are expecting it, that it can happen any moment from now. Okay. So with that, we say that this one is recording small variability, which is acceptable. Okay. So that is what businesses try to work around. They always want to work around small variabilities so that you don't surprise consumers, or you don't want consumers to rise up and then throw their arms all over. All right. So I'm sure I have given you comprehensive understanding about the average and variability, which I have used the grading system to explain and to also use a working environment to do that, so that the take home for you now is that there is always an average point as the starting point, okay? And there's always the beginning of the average data set as point 1 or destination 1. And then there's also another stretch the average can do to another destination called destination 2. The distance between destination 2 and the average is called the variability. Same thing, the distance between the average and the first destination is also variability. Last point, a lot of people are expected to be around the average every time. If it is a target to, a lot of people are expected to be around the target, not to exceed, but to be around the target every time. And we've also learned that there are a few people who always exceed the target. Not too many people, just a few people who always exceed the target. And then finally, also, we also have a few people who also work below the target. So if you're a good manager, you will try and put everything together. You put those who have exceeded the target and those who haven't exceeded the target. One should shore up the other. Let's say you have 200 employees, 180 of them have met the target. 10 of them have exceeded the target. And then 10 of them went below the target. You can't sack this 10 because some people have done well, which you can use to compensate these ones. So the only thing you do is that then you do more pep talk on those who fell below the target, the 10. You keep encouraging them, giving them all the necessary assistance they need to improve the next time round. So that is what you do as a good manager. You look in between your left and right and try and balance the targets you set for the two. Now, in conclusion to all I have said, these are the short highlights and summary I want you to always avert your mind to anytime it comes to average and variability. Always remember that the average will always represent the central value or the target value in any business performance, whether it's general performance or group performance. Always the average will be the central value. But that's not the only thing we need. We also need to know that the average will have to go through what we call variability or dispersion. It means that we can't just stand at the average. We have to spread out from the average. And when we spread out from the average, where are we going? We are going to the first point of the variability, or we are going to the second point of the variability, right from the average. When these things are clearer to you, then you can say that you fully understand any data that you are giving. This is the full understanding you can have about any data you have given, that you know both the average and the variability. And once you put them together, you know your starting point and then your ending point or your stopping point. So let's take an example and try and express all these techniques in them. And let's see whether they can make sense to us for us to understand a data we want to work with. Look at this data. Look at this exercise. This is showing mass measured in kilogram. So this could be either human weights or item weights. Okay. So let's say these are weights of some human beings or some persons. Let's say these are their weights. And look at the data that has been presented to us. It's saying all those who are weighing between 40 to 44, they are 4. All those weighing between 45 to 49, they are also 2. All those weighing between 50 to 54, they are 3. So and so on and so forth. So my interest is when you add all these frequencies together, you have 75. So it means that 75 persons have been weighed. And after the weighing, those who have weights between 85 to 89, it was only 1 person. And then those who had 80 to 84, you have 3 persons here. And then 75 to 79, you just have just a single person. Now the question is, this data, what can we do with this data? What lessons or what information can we get from this data? And that is what we have been trying to learn all day. That anytime you see data, there is an important metric to measure. That's the first thing you measure. You stop every other thing and you measure that metric. And that metric is called the mean or the average, as we have demonstrated today, the mean or the average. And then the second thing you need to measure is the variability, because the average cannot be static. It has to move. So you measure the variability. Okay. And one of the simple tools that is used to measure the variability is the standard deviation. When you are asked to find the average and the standard deviation, all they are seeking to do is to, like I just showed you a few moments ago, to understand the data. Anytime you want to understand the patterns of data, the trends of data, the patterns of data, these two information are very key. The average and the variability will help you know the pattern. And that's what this question is seeking to do. That first of all, find the mean or find the average, and then interpret your results. Secondly, find the standard deviation, and again, interpret your results. Interpret your results means that bring your understanding about what you have done. Bring the understanding in the data, because the data, as you see it, is speaking. The data is speaking. And if you don't apply good techniques, you can't hear the voice of the data. You need to hear the voice of the data. There is something in here which is hiding. We need to bring it out. And it's only the mean and the standard deviation that can help us to understand the data. So let's learn how to find the mean and the standard deviation. Again, because I haven't taught you before, if I'm not mistaken, the names are not familiar. I want to show you some formulas that we use in finding the mean and the data. So for the mean, this is the formula we use. X bar like this is equal to this Greek symbol, sigma fx over sigma f, where the sigma, this Greek symbol of sigma, it means add up or sum. So you are adding up something, or you are sum up something. Okay. F is representing the frequency that has been displayed in the data. X will represent the metric or class midpoint. Class midpoint. And I know you have seen this formula severally from JHS through SHS. That's what we use for the mean. And then the standard deviation, we use this formula. S is equal to, have the square roots of the same sigma. This time it is Fx squared divided by sigma F minus sigma Fx over sigma F all squared. So this is the formula you use. So if you are looking at the two, the variables you are seeing in are F and X. So that's what we need to do from our table. Initially, we have our class intervals here, which has been given in the question. This one is the class interval, 40 to 44, 45 to 49. And then we create the frequency. This is the frequency. So that has also been given to us already. So we have our F. And then we look at the formula. The formula, we have this X. So we'll create X here this way. And then we keep going. Now we want F times X. And we create F times X. And then we look at this formula too. I see F, we have done it already. I see F, we have done it already. I see Fx again, we have done it already. But look at this one, we have Fx squared. It's different from Fx. Fx squared. It means pick this Fx and then multiply it with this X to get you your Fx squared. And if you do that well, this is the table you are going to generate. So you have your class intervals in the weight 40 to 44. Then you have the corresponding frequencies. They are here. Okay. So you have them as well. And then once you have them, you total this frequency from the 4 to the last frequency. And when you do that, you have this one here. So this is your total frequency, which we are writing as sigma F. So that is that. Then we come here and create your X. Those of you who have forgotten how to create this X, all you do is pick the first number here, add it to the second number here, and then divide it by 2. When you do that, you have 42. You do same for the second one. 45 plus 49 divided by 2. You have 47. So you keep doing for all of them to generate all these numbers from the top to the 87. So 87 will be 85 plus 89 divided by 2, you have 87. Once you have the X, if you look at the formula says sigma Fx. So you multiply this F and this X, and that will give you this one. So 4 times 42 will give you 168. 2 times 47 will give you 94. You do the same for the others, and then you keep coming down. Finally, you add all, and then you have 4690. So this will become your sigma Fx for 4690. And then you pick the mean. So we can now calculate the mean. So the mean says sigma Fx over sigma F. You pick your 4690, you fix it here, like I've done. You pick your sigma F75, you also fix it here. When you divide this, your final answer you have is 62.53 kilograms. 62.53 kilograms. Let's go and look at the interpretations. What is this 62.53 kilograms? If you come, this is the interpretation. It means that the average mass or weight of the individuals is 62.5 kilograms. That is the average for all the 75. But the question is it true that all the 75 are weighing 62.53? No. Some are weighing 45, some are weighing 49, some are weighing 55, some are weighing 50, some are weighing 80, some are weighing 84. So the average alone is not enough. It has to show us that if this 62.53 is lying somewhere here, if this 62.53 is lying somewhere here, are there some weights which are coming down from 62.53? Are there some weights which are going up? And this is what we have learned today. How do we know that? We can only know that when we find the side or variability. We need to find the variability. That will show us that when you stand at the center, you can also move elsewhere to see some weights. And then you can also move downwards here, another variability to get some weights. So let's try and find that one also, the variability. Now the variability, the standard deviation, this is the formula we wrote. Square root of sigma fx squared over sigma f minus sigma fx over sigma f all squared. If you go to the table, we have this one there, no problem. If you go through the table too, we have this one, the same thing. We don't have a problem. That was the 75. So we don't have a problem. If you go to the table to the fx, we have it. That was where we had the 4690. So now our problem is we don't know this one. Sigma fx squared. We don't know it. So we have to go and form that column on the table and find it. And that was what I did here. So I came to this side and then I formed the fx squared. If you want to remember how we had the fx squared, this is what we do. Look at the x. The x is squared. So it means that this fx squared can be written as fx squared is the same as fx, like this, multiplied by x. When you put the two together, it will give you fx squared. So I picked this fx, like I've written here. I picked this x, and then I multiplied the two, fx by x, and that one gave me the fx squared. So I did it for all of them, and then I had the total to be 299,460. After getting it, I went to the formula, and then I came to fix it here, 299,460. After working this one with my calculator, I had 9.1 kilograms, being the variability. So what does it mean? it means that when we pick the center, which we had 62.5, when we are going to the right like this, we should add 9.1. So if I add 9.1 to 62.5, I'll have 71.6. If I come to the left, it means I should subtract. So when I subtract 9.1 from 6.5, this is what I'll get. I have 4, I have 3, I have 5. I'll get 53.5. Okay, so look at the variability. It means that from the center, you can have some people whose weight are 53, and also you can have some people's whose weight are 71. And if you go to the data, you see that that is true. After you get your center here, you can have some people whose weight are 53. They are here. You can also have other people whose weight are 71. They are also here. In fact, that is not enough. You can even keep going. You can also add again another 9.1 to this one. So if you have 71.6 plus 9.1, you will have 7.08. So you have 80.7. If again you come back here and you subtract 9.1 from 53.5 minus 9.1, if you do that, you get 4.4 again, 4. So you have 44.1. Let's check whether we can see some persons who were having weight of 44 and some persons who were having weight of 80. We'll see it in the table. Look at the table again. We have people who were having weight of 80. And we have people who were having weight of what? 44. So this clearly shows you that when your mind comes on the average alone, which we found to be 62.5, and you stay here, we will have no information going up or no information coming down, except we find what we call the variability. It is the variability that is going to show us our movement from the center, how far we should move from the center up, and how far we should move from the center below. And that is all I wanted to teach today. So in summary, what we can say about our data is that the mean mass or weight, the mean mass or weight, in other words, the mean also means the average. So the average weight that we are learning from our data is that most people should weigh around 62.5. Most people should weigh around 62.5. And then what are the differences? The differences after getting this, moving to the right and then moving to the left, the differences should be 9.1. We should take you to the next people. And then if you want to go again, we'll do another 9.1 and it will take you to another group in the table until you cover all the group. Now, what conclusion can we give? If you look at the table again, we are saying most individuals fall within 53 to 72 kilograms. Most individuals fall between 53 to 72. Let's check whether it is true. If you remember what I did at the other side, I won't go there, but I want to do it here again so that you understand what I've written here. That will be my last statement. This is what I did. When I was coming here, I told you the variability is 9.1. So we just add 9.1 to 62.5 plus 9.1. You have 6. You have 71. So 71.6, if you approximate it to the nearest whole number, you have 72. So let's put 72 here like this. And then when we're coming to the left-hand side, we do the same thing. This time we are going to subtract 9.1 because we are coming to the left. And we did 62.5 minus 9.1. And then we had 4, 3, 5. We had 53.4, which when you approximate to the nearest whole number, you have what? 53. So it means that you have 53 on the left. So I'm saying that according to the drawing I showed you today, which I quickly want to go back and then come, if you remember, when I was showing you this drawing, watch again. I told you that always most people will have to be around the average. If you look at what I wrote here, I said always most people will be around the average. But if you move far away from the average, you just have some few people who are away from the average. But most people are around the average. So if you look at our results now, our results is telling us from the calculation here that most people who can lie around the average, this is around the average, who can lie around the average are from 53 to 72. Let's go and check on the table whether it's true. Let's look at the question we were given, whether our findings is true. And that's what I called the evidence. Let's go and check the evidence, whether what we have calculated is true. Now watch something. The answer we had was in this range. We had 62.5. When we were moving up and down, so when we came down, we ended at 72 from our calculation. And when we were moving up, we ended at 53. Now watch it, 53 is here. It's in this range. And look at 72 too. 72 is here. Now let's look at the numbers now. I'm cutting the line. Look at the line I'm cutting. So watch. Most of the people are lying here. Look at it. And just a few are lying outside. So here you have a total of 6 people who are outside the 53. Look at this side too. You have only 5 people outside the 72. But look at the bulk of the people here. When you add this to this, you have 35. 35 plus 3, 38. 38 plus 17, that's 55. Plus 9, 64. So you have as many as 64 lying around the average. And that is what we have proved. that always, the moment you have 1, the average, and then the moment you have the variability up, variability down, when you combine the two, it helps you to understand your data. And always you will find a lot of people lying around the average, which makes a lot of sense. If you want to use weight to work, what you do is that the weights here are not bigger. You can ignore them. The weights here are too much. You ignore them. But the weights here, we say they are acceptable. You can work with them. And that is what we have done today by learning about the concept of the average and the variability. I have 4 minutes. Any question for me? I'm sorry, I have used a lot of time in explaining. Any question about what we have done today? Yes, Ezekiel, you can unmute yourself and ask your question.
Oh, yeah, good afternoon. It's not a question. I was just giving a thumbs up. You've really explained things well. Thank you.
All right.
Hello?
Thank you so much.
Oh,
Thank
okay.
you.
All right. Thank you too.
Any question? All right. So thanks so much. So on that note, I wish you watch the video again. If you have any issues, you can let me know in our next class. But I'm happy we have all taken off well, and I hope to build on it next week, God willing. Thanks so much for your patience and for sitting through the 2 hours class. On that note, officially the class is ended for today.